Hi, in this video we're going to be working on section 4.2, which is prime factorization and simplifying fractions. Okay, so we're going to start with prime factorization first. The basic idea here with prime factorization is you take a number and you write it as a product of primes. Remember, product means multiply. So we're basically going to just keep factoring the number into little parts until it can't be factored anymore. Okay, so let's see an example of prime factorization. Okay, so example, find the prime factorization of each number. Find the prime factorization of each number. Okay? And for example number 1, we're going to find the prime factorization of the number 54. Now there are a lot of ways of doing this, finding a prime factorization, but probably the most common, easy way of doing it is with a factor tree. Okay, so actually let me give myself a little bit more room here. I'll put 54 in the middle here. So what we're going to do is we're going to make a factor tree. And the way you make a factor tree is you think of numbers that multiply to 54, and then you start making what's called a tree. Okay? So for numbers that multiply to 54, most people know from your times tables that 6 times 9 is 54. So when you're making a factor tree, you draw these lines, diagonal lines, and then you write the numbers that multiply to this number. So this means 6 times 9 is 54. But because it's a prime factorization, prime means you have to factor it all the way. So we aren't actually done here. We still have to factor the 6 again, and then we can also factor the 9. So we keep going here. Okay, so from your times tables, everyone should know that 2 times 3 is 6. So we're going to write 6 as 2 times 3, like that. So I'm just continuing my tree. Okay, and then 9, you should know that 9 is 3 times 3. So to finish factoring 9, we're going to write it as 3 times 3. And then you know you're done factoring when all these numbers on the bottom are primes. Okay, so this thing that we made here is called a factor tree. And why is it called a factor tree? Well, because it looks kind of like a tree. It doesn't look 100% like a tree, but you can sort of see a tree-like shape. Kind of looks like a Christmas tree in some ways. All right, and once you've gotten to the bottom here and every single number is a prime, that means you're done. Okay, and what people like to do is they like to circle the numbers on the bottom. These are all the primes. And a number is prime if you just can't factor it anymore. Okay, so 9 is not a prime because we were able to factor it, but 3 is a prime because you can't write 3 as the product of any two numbers except for 3 and 1. Okay? So what does that mean? With this factor tree, we've actually developed a prime factorization for the number 54. So our answer is going to be 54 equals 2 times 3 times 3 times 3. Okay? So that's actually, if you multiply these numbers out at the end, you're going to find that you should get the original number 54 here. And then rather than writing it as 3 times 3 times 3, you actually want to write repeated factors like 3 as an exponent instead. So remember, an exponent tells you how many times you multiply a number times itself. So here, the 3 times 3 times 3, you are actually going to want to write that as 3 to the third power, because there's 3 3's there. Okay, so I'm going to go ahead and, instead of writing 2 times 3 times 3 times 3, I'm going to write 2 times 3 cubed, or 3 to the third power. Okay, and then this thing right here is going to be our answer. So 2 times 3 cubed, this is called the prime factorization. Prime factorization. And prime factorization just means that we've written 54 as a product of primes. So we've written it as a bunch of primes multiplied together. Okay, and sometimes your prime factorization will have more than 2 factors. Sometimes it'll have just 1 factor if it's already a prime. Okay, so that's example number 1, and I wanted to do a few more examples so that we can get the hang of this. Okay, so problem number 2, same instructions. Find the prime factorization of the number 16. Find the prime factorization of the number 16. So hopefully you're good with your times tables. Most people should be able to think of 2 times tables that give you 16. Your 2 options are either going to be 4 and 4 or 2 and 8. And either is fine, honestly. As long as you can come up with 2 numbers that multiply to 16 and you factor all the way, you're going to get the same answer either way. But I'm going to go ahead and factor 16 as 2 times 8, just so that you can see what happens. But you can also do 4 and 4. Just make sure you keep factoring all the way to the bottom. So if we factor 16 as 2 times 8, we can't factor 2 anymore, right? We can't factor 2 anymore, but we can keep factoring 8. And we have to factor all the way to the bottom where we just have primes. Okay, so where we just have numbers that can't be factored anymore. Okay, so with 8, what are 2 numbers that multiply to 8? Well, from your times tables, most people should remember 2 times 4 is 8. So we're going to factor 8 as 2 times 4. Okay, and then are we done? Well, no, because we can still factor 4. So how does 4 factor? Well, 4 actually factors as 2 times 2. And now we know that we're done, because if you look at the very bottom of each of these branches, people like to call them branches because it's a factored tree, so a tree has branches. If you look at the bottom of each branch, all these numbers are primes. They're all 2, and each 2 is a prime. So we found the prime factorization. So I'm going to circle all the primes here. So the primes are 2, 2, 2, and 2. So with this one, the prime factorization is going to have a total of 4 2's. So this is going to be 16 equals 2 times 2 times 2 times 2. But remember, you're not supposed to leave your answer as the same number multiplied times itself. So whenever you have repeated factors like this, you have to rewrite it as an exponent. So rewritten as an exponent, we have a total of 1, 2, 3, 4 2's. So we're going to write this as 2 to the 4th power. 2 to the 4th power. Okay. So we have 16 equals 2 to the 4th power, and that's our prime factorization. Okay. All right. So that is example number 2. And then sometimes the numbers don't show up in your times tables, so that could be a little bit more challenging. So I wanted to show you some problems that don't show up in your times tables. Okay, so problem number 3. Here we want to find the prime factorization of 176. The prime factorization of 176. Now the thing about 176 is it doesn't even show up in your times tables, right? The biggest number that should be in most times tables is 144. However, what you can do is you can try dividing by different numbers. Okay, so let me write this down. Try dividing by different numbers. Okay, and if you want to, you can use a calculator, because that can speed up the whole process. Otherwise, it can take a while to divide stuff. But like if it's an even number like this, remember an even number, the last digit is either 0, 2, 4, 6, or 8. If it's an even number, you can immediately try dividing by 2. And if you don't want to write it out, just use a calculator. You can even just use the calculator on your computer. That's what I'm going to do. So I see that 176 is even, so I'm going to divide it by 2. So I'm going to do 176 divided by 2 and see what that gives me. That gives me 88. Okay, so what does that mean? Well, if 176 divided by 2 equals 88, that means that I can write 176 as 2 times 88. Alright, so plugging that in, I've actually started to factor 176. So it's going to factor as 2 times 88. Okay, so even though it wasn't in my times tables, I just tried dividing by 2 and I saw that it gave me 88, so that means 176 is 2 times 88. Okay, and then once we got to 88 here, then hopefully you remember 88 from your times tables. So 88 is actually 8 times 11. Okay, so I'm going to go ahead and factor that. 88 is 8 times 11. Alright? And we can't factor this 2, and we can't factor the 11. Those are both primes. But we can still factor the 8. So why don't we finish factoring this 8? So how does 8 factor? 8 factors as 2 and 4. And then are we done yet? Well, not quite. 4 is not a prime number, so we can still factor 4 as 2 and 2. So that's going to be our last step. Okay, so 4 is 2 and 2. And then once again, I like to circle all the primes. So the primes we have here are 2, 2, 2, 2, and then 11. Okay? So I'm going to rewrite this as 176 equals 2 to the, well, let's see, how many 2's do we have? 1, 2, 3, 4 2's. So that's going to be 2 to the 4th power. 2 to the 4th power times 11. And that's going to be our answer. So our answer is 2 to the 4th power times 11. Okay, so calculators and just dividing by numbers like 2 or 3 will usually let you deal with a bigger number like this. Because most numbers are either divisible by 2 or 3 or maybe 5. Or if it's a really hard number, it'll be divisible by 7, that kind of thing. So using a calculator, or even if you don't want to use a calculator, you can write it out. You can just do 176 divided by 2 by hand as well, and you should still get 88. Okay, So it's still possible to do a problem when it's not actually in your times tables. Okay, so I'm going to do a couple more of these before we move on to the next topic. Okay, so example number 4. Find the prime factorization of 105. 105. So this is another number that's big enough that it doesn't actually show up in your times tables. And notice it's not an even number, so that means we can't divide it by 2. So what can we divide it by? Well, remember, if your last digit is 0 or 5, that means it's divisible by 5. Okay? So going on my calculator again, I'm going to go ahead and try dividing 105 by 5. Okay, so I'm going to do 105 divided by 5 and see what that gives me. And that gives me 21. So 105 divided by 5 is 21, which means I can factor 105 as 5 times 21. 5 times 21. Okay, so 105 is 5 times 21. And then we shouldn't need a calculator for the rest of this, because 5 is a prime number, can't be factored. But 21, from our times tables, we should know that 21 is 7 times 3. Okay, so 21 is 7 times 3. Okay, and then 7 and 3 are prime numbers, so we know that we're actually done here. Okay, so then circling all the primes, we have 5 times 7 times 3. And people usually write them in increasing order. So the smallest number there is going to be 3, so it's going to be 3 times 5 times 7. That's going to be our prime factorization. Okay. Alright, so I wanted to skip ahead to probably one of the harder ones. Most people don't find these that challenging though. I just wanted to do one more just to make sure we can deal with big numbers. So example number 5 of finding a prime factorization. For this one we want to find the prime factorization of 300. Okay, the prime factorization of 300. So now, once again, this is a big number that isn't in your times tables. There's a number of ways you can factor this, but for example, you might notice that this is an even number, or you might also notice that because it has a 0 as the last digit, we can divide it by 10. Okay, so you could either divide it by 2 or you can divide it by 10. But I'm just going to go ahead and divide it by 10 using my calculator. So let's do 300 divided by 10. See what that gives us. It actually gives us 30. And, you know, a lot of you might be able to do that in your head because 10 times 30 is 300. Okay, so that means we're going to factor 300 as 10 times 30. 10 times 30. But you could have also divided by 5. That would work too. Or you could have divided by 2. There's lots of numbers that you could divide it by. But as long as you go all the way down and factor everything out, you're still going to end up with the same prime factorization at the end. Okay, so 10, how does that factor? Well, from our times tables, we should hopefully remember that 10 is 2 times 5. Okay, so we're going to factor 10 as 2 and 5. And then what about 30? Well, you can either write it as 3 and 10 or 5 and 6. I'm going to go ahead and factor it as 5 times 6. Okay, and then am I done? Well, not quite. I still have this 6 here that isn't a prime. So how does 6 factor? 6 factors as 2 and 3. Okay, and now we've gotten to all primes on the bottom. So now I'm going to go ahead and circle all the primes. So we have 2, 5, 5, 2, and 3. So here they're a little bit out of order, but you still want to write the correct exponents. So first I'm going to start with the smallest number, which is 2. I see a total of 2 2's. So that means in our prime factorization, we're actually going to have 2 squared, or 2 to the second power. And then I also have 1 3. That's the next biggest number. So that's just going to be times 3. Times 3. I mean, you could write times 3 to the 1, but that's not really the way people write it, right? If the exponent is 1, they just write the number. Okay, so you're just going to write times 3. Okay, and then the last number is 5, and we have 2 5's, so that's going to be 5 squared, or 5 to the second power. So the prime factorization here is 2 squared times 3 times 5 squared.